Okay, on Tuesday this week, what we covered was negative area, trapezoids. Those were 11C and 11D in your book. And then the big thing is indefinite integrals, definite integrals, and antidifferentiation. So this is like the backwards of derivatives. So this is basically negative area. I have this black curve right here, and sorry, it's covered up a little bit. It's the curve x squared minus 1, and I just am caring about it from 0 to 1.5, so that's why I have this restriction on that. This section down here is actually negative area, and if you ask Desmos to calculate the area here, it will give you a negative answer. This part is positive area because it's above the x-axis. And the way that you want to think about that is imagine that this curve is velocity. So let's say this is a velocity of like Perkins running, who knows. If that's the case, then down here what it's saying is that I have negative velocity. And negative velocity just means that I'm moving in like the left direction or down. So if you think about there being some sort of home base that's like 0, then I'm running to the left, running to the left, running to the left. At this point, I turn around and I start running to the right. Anything over here would be me running to the right. Here I'm doing it kind of slowly, here I'm doing it a lot faster. Here I'm like running to the left pretty fast, and then I have to slow down so I can turn around, and then I move to the right. This area right here is going to represent how far to the left I ran. This area would represent how far to the right I ran. And then if you actually did the integral here, the integral of x squared minus 1 dx from 0 to 1.5. Let's actually go ahead and do this. This will kind of preview what we're going to do for the rest of the lesson. This would be equal to, when I use this and this, I'm basically asking, can you backwards differentiate? So backwards find the derivative. And for x squared specifically, that would be 1/3 x cubed. You are welcome to double check me. If you take the derivative of this, you're going to get x squared. And then minus x, because the antiderivative or the backwards derivative of 1 is just x. And then in this case, and we'll talk a lot more about this later on, you'd have a plus c, but we're gonna get that to subtract out. Okay, so now I gotta deal with the 0 and the 1.5. I don't know why this thing keeps like skipping in and out. It's kind of annoying. Like that. Why is it doing that? Ugh, super annoying. Okay, so here's what I'll do, is I will use that 1/3 cubed minus all of that. I'm going to do twice. And I'm just going to kind of keep writing over my whole graph here. 1/3 of this cubed minus that. And in both cases, we could add the plus c. But one thing you'll notice right now is that this plus c and this plus c, they're going to subtract out. Important to note, because positive c minus c is going to subtract out. Now what I'm going to do is I'm going to plug in the bounds, 1.5 and 0. So 1.5 here and 0 here. Over here, I'm going to get a grand total of 0. That worked out kind of nicely for me. Over here, I'm going to need a calculator. And I get negative 375. Oops, that's not a 7. 75 thousandths. Minus 0, my total answer is negative 375 thousandths. And basically, what that means, if we go with this whole Perkins running thing, is that means that I ended up 0.375 feet, meters, miles, whatever we're counting here, to the left. That negative just means that I ended up to the left. Because when you differentiate or anti-differentiate, you're going backwards. So if this is velocity, I'm getting displacement. So this right here tells me my displacement is from 0 to 1.5 seconds, or could be hours, whatever. I didn't actually label anything here, is 0.375 units to the left. That's what that negative tells me. So just so you know, negative area can exist. It doesn't mean that like this area is somehow like a void in the universe. It just means that I'm talking about, in this case, negative means left or down. as opposed to positive, which means up or right. Cool. The trapezoid rule, this is part 11D in your book, basically just says instead of using these rectangles where I kind of like, if you look at the white rectangles here, I underestimated, I overestimated, I overestimated. If you actually use these lovely, lovely trapezoids like that, or like that, that you'll get a much better estimate of the area, and it gives you a formula for doing that. Look at my answer, that might be helpful. But we're gonna kind of skip over this because it's just less important. Okay, here's where we're getting to actual antidifferentiation. Now, in order to go this way, right, where I start with f of x and we end up with f prime of x, you guys know what to do. X cubed gives you 3x squared. X to the fourth, 4x cubed. X to the fifth, 5x to the fourth. Cosine gives you negative sine. Then natural log gives you 1 over x. E to the x gives you e to the x. But what happens over here when this time we're going that way? We're moving to the, from the derivative over to the, or from the derivative back to the original function. And what you're gonna see is this. 1/2 is gonna become 1/3 x cubed. 1/3 is gonna be 1/4 x to the fourth. 1/4 would become 1/5 x to the fifth. Sine would be negative cosine. 2 over x would be 2 the natural log of x, and this would be 5e to the x. All of these are part of your formula packet, and you can definitely look in there, but start thinking to yourself, okay, why is this? And a good way to check if you've gone backwards correctly is to go forwards again. So 3 times 1/3, oh hey, that's a 1. So there's no coefficient over here, it's just like that hidden 1. And then 3 minus 1 gets you 2. Cosine has a derivative of negative sine. Oh, negative cosine would be negative sine, which is positive sine, etc. So what we're doing here is just like mechanically figuring out how do I go back. So if you look at your formula booklet, this and page 11 and 12, this is page 11, it has this very fancy rule for you, which is that the antiderivative of x to the n dx is always x to the n plus 1 over n plus 1 plus c. That would look like here. So x cubed, we'd have x to the 3 plus 1 over 3 plus 1 plus c. We're going to talk about the plus c in a second. But this would just get us x to the fourth over 4, which is totally okay to write as 1/4 x to the fourth. X to the 7th would become x to the 8th over 8 plus c plus c. X to the 14th would be x to the 15th over 15 plus c. And then if you had something like this where you have a coefficient with the power, really just set that coefficient aside. So you're still going to have that, and the antiderivative of x to the 9th is x to the 10th over 10 plus c. And then you can deal with like, oh, 5 over 10, that gets me 1/2 x to the 10th plus c. Let me know if you have questions about that rule. On page 12 of your formula booklet, you'll see the rules for all of these. 1 over x is ln of x. Sine is negative cosine. Cosine is sine. 1 over cosine squared is tangent, and e to the x gets us e to the x. Okay, so on here we're going to be like y plus c, like what the snot is Miss Perkins asking about. Well, let's take the derivative of all of these. Y equals x to the fourth. Okay, that's not so bad. That would be y prime is 4x cubed. Cool. This one, y equals x to the fourth plus 7. Oh, that would be the same thing, right? Because the 7 would drop out. So you just get 4x cubed. And then x to the fourth minus pi. Oh, that would also be the same thing. So really the question is, I can go this way, but when I go backwards, what's the antiderivative of this one? Is it this one? Is it this one? Is it this one? And the answer is you have no idea. So that's why we have to add this plus c, because we don't know which one specifically it was. We know that the pink is the derivative of all of the whites, but I don't know for sure if I start with the pink and I want the antiderivative, which one of these it ended up being. So that's where you get your plus c. So here's an example from the book of like how to find the plus c. So like figure out which one it actually is. And what happens really is that you have to get another piece of information like this. So here we have f of x passes through this point. F prime is this, and they want to know what's f of x. Well, my first job is going to be taking the antiderivative of 2 minus x over 3 dx. And by all means, double check me, but go use those formulas. You're going to get that it is 2x minus 1 over 6 x squared plus c. And then, so what we've basically found is that f of x looks like 2x minus 1 over 6 x squared plus c. But then don't forget that this, we normally write this as xy. We could also write this as x f of x, because y and f of x are the same thing. So all I'm going to do is I'm going to replace that f of x with 3. I'm going to replace x with 1. And I'm going to write in that whole rest of this. And then we can solve for what c is. Here we'd get 3 is the same as 2 minus 1/6 plus c. I'm going to change everything to sixths just so I can deal with that. And so we'd have 18/6 is the same as 12/6 minus 1/6 plus c. This is 11/6. 18/6 minus 11/6 is c, which means that c is 7/6. So then, back up here, we could actually plug in and get that our final formula, like the original function, is f of x is equal to 2x minus 1/6 x squared plus 7/6. Okay, let me know what questions you've got. Happy to help. Hope you're doing great.